This section is about the multiplication rule for independent events. Remember, independent events means they do not affect each other. So if we have two independent events, then the probability of A and B, so this is our intersection, is equal to the probability of A times the probability of B. So probability of A and B, that's our intersection. And independent means they do not affect each other. And this rule can be extended if you have more than two events. You just multiply all of the probabilities together. So let's try. Remember the problem with a quiz consisting of 3 true or false questions where you blindly guess. Let's find the probability of being right, wrong, right. So the probability of right, wrong, right. Now when I write that, that's shorthand for the probability of right and wrong and right. And if you want to find the probability of ands, we multiply. So this will be the probability that we get the first one right times the probability that we get the second one wrong times the probability that we get the third one right. So it's true, false. That means there's only 2 choices. You're blindly guessing each thing to be equally likely. So the probability of getting one right would be 1/2. The probability of getting the next one wrong would still be 1/2. And the probability of getting the next one right would be 1/2. So if you multiply all of that together, you get 1/8. But now what if the quiz consisted of 3 multiple choice questions? So multiple choice questions with 4 choices. And again, we're blindly guessing. So now if there's 4 choices, that means the probability of a right would be 1 out of 4. So probability of a right would be 1 out of 4, which means the probability of a wrong, there's 3 wrong choices, so 3 out of 4. So we want the sequence of right, wrong, right. So the probability of right and wrong and right, you'll just multiply each of these probabilities. So probability of right times probability of wrong times probability of right. So right is 1/4, probability of wrong is 3/4, and probability of right is 1/4, which gives me 3 out of 64. Okay. So a different probability because now we had 4 choices, so it changed the probability of us getting one right. Okay, in this example, there are 4 blue, 5 red, 1 green, and 2 white marbles in a bag. Assume that after you draw a marble, we put it back. So this is going to be with replacement. And then draw a second marble. So with replacement. With replacement means that our events will be independent, that they shouldn't be affecting each other. And so our first and second marble will be independent. So let's find the probability of getting a blue and then a white. First of all, it might be useful to total up our number of marbles. So I have 4 blue, 5 red, 1 green, 2. So 4 plus 5 plus 1 plus 2 gives me 12 total. So I want the probability of blue and then white. So this will be the probability of blue times the probability of white. So I had 4 blue out of 12. Then if I want a white one, I put the first marble back, so we're still going to have 2 white marbles, and we still have 12 marbles total because we put the first one back. If I put this in my calculator, it gives me 1 out of 18. And probability of green and then red, so probability of green and red is going to be the probability of green times the probability of red. So I have 1 green marble out of 12, and red, let's see, I had 5 red marbles, it's still out of 12 because we put the first one back. So I get 5 out of 144. What if I have the probability of blue and then blue? So the probability of blue and blue. So probability of blue times probability of blue. Now you might notice sometimes I'm actually doing the intersection symbol, sometimes I'm writing the word and. I just kind of want you to be used to both. So for the probability of blue, looking back up here, I have 4 blue marbles. So I would have 4 out of 12. Then I want another blue marble. But notice, again, we're putting the first one back. So it's not going to affect us. So we put the first one back. So the next one will still be 4 out of 12. Or 1/9. The probability that a person takes a positive test result is 0.02. Assume the results for different people are independent. So different people aren't affecting each other. So I would write here, just for future reference, probability of positive is 0.02. Now, if one person takes the test, what is the probability of a negative test result? Well, probability of a negative would be, let's see, if our positive is 0.02, then a negative would have to be 1 minus 0.02. We can use the complement rule there to find the probability of a negative is 0.98. Now, if 5 people take the test, what is the probability that they all have positive test results? So this is basically saying probability of 5 positives. And you ask yourself, how do you get 5 positives? Well, to get 5 positives, you have to have the first one be a positive, and the next 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 one be a positive. And to find the probability of all of these put together, we're going to have to multiply. So the first positive is 0.02, the next one is 0.02, 0.02, 0.02, 0.02. Because they're not affecting each other, because they're independent, the probabilities don't change. The probability of a positive for each person is 0.02. So we put all this in, and we get 3.2 times 10 to the negative 9. If you don't remember what this means when you see it in your calculator, go on to Google and search for scientific notation. Okay. If that changes to 0.00000000032. So that's a pretty small number. Now, if 5 people take the test, what is the probability that the results are in order? Positive, positive, negative, negative, negative. Okay. So I'm looking for probability of positive and negative and negative and negative. So probability of positive is 0.02. Another positive is 0.02. A negative is 0.98. 0.98, 0.98. So this gives me 0.000376. What about if 50 people take the test? What's the probability that all the results are going to be negative? So probability of 50 negatives. Well, this would be the probability of a negative and a negative and dot 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 and a negative. I'm going to have to do that 50 times, right? So the probability of the first negative is 0.98. The next one is 0.98. Up to the last one, which would be 0.98. And again, I had to do that 50 times. So instead, I could put this in my calculator as 0.98 to the power of 50. And this gives me 0.364. So even though the probability of one negative is 0.98, and that seems pretty big, by the time you look at 50 different people, the probability that every single one is negative ends up being a lot lower at 0.364. Now, if 50 people take the test, what's the probability of at least one positive? So at least one positive. So the probability of at least one positive. To do this, we're always going to use the complement rule. So we'll do 1 minus the probability. So what's the opposite of at least 1? The opposite of at least 1 is 0 or no. So we'll do 1 minus the probability of no positives. And if that part didn't make sense to you, don't worry. We have a whole, try it on your own later. where you can discover why we do it like this. So again, the complement of at least one is no, or none. So we'll do 1 minus the probability of no positives. So this will be 1 minus the probability, no positives really means 50 negatives. And we found that right up here. So it'll just be 1 minus 0.364, which gives me 0.636. So the probability of at least one positive, even though the probability of positive is only 0.02, the probability of at least one out of 50 people is pretty high at 63%. Now I have another now you try problem, and again this at least one. It is very important you do this because we are going to be using this throughout the rest of the semester, or at least the rest of the probability unit. It's very useful. Make sure you do this to understand what I'm talking about.